PPA assignment 6. We would like to create a simple door maze game. In this game there are a number of rooms arranged sequentially. The player starts in the first room and must travel through each room in the sequence until they reach the final room, in which case they win the game. However, in order to go from one room to the next in the sequence, they must choose between two doors, a blue door or a red door. Note that the door which they use to enter the room is ignored, as the player cannot go back. Only one of the two doors leads to the next room, whereas the other one lets in a monster, which attacks the player before retreating back through the door which it came from. This results in the player losing a life. The player may pick a door again if they have at least one life left, otherwise they lose the game. Okay, model this scenario based on the following requirements. A room has a name, room is in capitals there, so we know it has to be a class, and then we have this lowercase n here for name, which suggests there's going to be a field here, private string name. Also, it contains a blue door room, which is the room that the player will go to if they choose the blue door. Okay, so now we have another field. It should be very familiar now that we can reference class type fields, and perhaps the first time I think we've seen it in the assignments, we're actually going to reference that field, the class type itself, from one of that class's fields. So in the same way that we saw a bank account, we saw the transfer method inside bank account take objects of type bank accounts, objects of its own type. We know that we can reference the class type itself from within the class, if that makes sense. So effectively we can have a field inside room which is of type room. And this makes sense because we could have multiple room objects, and we're able to not just pass objects of a different type into each other, but also objects of the same type into each other. So I could have a room class here where one of the fields is of type room, and again that's something that we saw way back when in topic 4, when we looked at this idea of a bank account taking parameters to one of its methods, the transfer method, which was also of type bank account. And there was this graphic that I put on YouTube as well, which you can watch if you want to convince yourself of how objects of the same type are passed into each other. It's exactly the same way as objects of different types. So a meal going inside, a dish going inside a meal is different classes, but it's fine for these to be the same classes too. So a room links to another room, which makes sense that there should be a field inside room that declares this, and I'm told this should be called blue door room. And I'm also told that there should be another room, so two connecting rooms, one through red door, one through a blue door. So blue door room, red door room. So fields that are going to hold objects that are the same type as the class in which these fields reside. There we go, that was more succinct. So it contains a blue door room, which the player will go to if they choose the blue door. Similarly, it contains a red door room, which is the room that the player will go to if they choose the red door. Next, it has a status contains monster, specifying either the room does or does not contain the monster. So we're going to, obviously, does or does not, two states. This is going to be a boolean, contains monster. Lastly, it has a status is final room, indicating whether or not the room is the final one. Again, whether or not, true or false, another boolean. So private boolean is final room. If any of these field declarations aren't familiar to you, obviously go back and look at earlier videos where I talk in more depth about what's going on here. 1.2, a player has a name and the number of lives left and the current room at which they are on, which they are in at any point. But first of all, let's set up the constructor here. So public room, string name, room, blue door room, room, red door room, boolean contains monster, boolean is final room, start name equals name, start blue door room equals blue door room, start red door room equals red door room, this dot contains monster equals contains monster. This dot is final room equals is final room. Okay. So let's, after doing this now, let's move on to player. So again, I want a player here. A player has a name, so again, same idea, private string name for the name of the player. A player has a number of lives left and the current room in which they are in. So obviously number of lives, I guess it makes sense for these to be whole numbers, so int lives. And again, a current room which they're in at any point. So again, now we again reference or we use a type of one of our own classes as we did with room, but this time it's not referencing itself as room did here. So a room reference to other rooms. This player is going to reference a room which is obviously a different class, and we're going to call that current room. Again, let's have a constructor. So I'm going to start off with quite strict constructors here and then see what kind of issues that gives me. So I'm going to say string name, int lives, room, current room. This dot name equals name. This dot lives equals lives, and this dot current room equals current room. Okay. Player can, so this is 1.3 now, a player can move to a supplied room. We will assume that the supplied room is the one that's linked to the player's current room either via the blue door or the red door. So what that means is we're not going to expect someone to try and jump to a future room. If this were going to be the case, then I guess they could effectively cheat. But that's not a kind of restriction we're going to think about, just to keep things simple. Remember, we're always trying to test you in the right way. We're not always looking for perfectly unbreakable solutions unless otherwise specified. So we can say public. So it's going to want to move to a supplied room, and then the method returns a result stating if the supplied room was the correct choice or not. Okay, so we'll see there's lots of people asking questions, particularly in relation to return types across all these assignments, as in why does my method have to return certain values, and we'll talk about that in a second. So public boolean, you can state whether a player can move to a supplied room. So we're going to say move, and obviously there's a supplied room, so obviously it's a room type, supplied room. And what I'm actually going to do before I even think about, I'm going to say return false just for now. Like I did in the last video, before I think about implementing this functionality further, I'm going to skip ahead again and test out the room objects that I have. So I'm asked to create my final class, which is the door maze game. I'm going to put a main method in here. And I'm going to go ahead and test out my my room class. So remember, I did this exactly the same thing in the last video. I left one of the methods kind of empty, so I know I'd done that bit of functionality. So if I've kind of entered the interface, then I know I can skip ahead and test out these classes, because I know that the methods that I want to interact with will be there and waiting, because I've got the interface, right? The name of the method, what it accepts and what it returns. So then I can kind of delay my implementation of this this method until later, which is kind of something that I did last time, and also something that I showed or will show, where you can see in the noughts and crosses example. So the interface in there is fine, so we can skip ahead. I wouldn't skip ahead unless you've completed the interface of the classes, but we skip ahead now just to test things out and see if what we've got so far is acceptable. So create a door maze game, which can be compiled and run from the command line. Obviously that means we need a main method. Use this class to do the following in order. So this refers to 1, 2, and 3, not necessarily the order within the objects themselves. But I'm gonna do this. I'm gonna do this anyway. I'm gonna actually stick strictly to the order inside 2.1 to see what the effect of that is. Okay. So first of all, let's make a. So if I make a. Let's not make the monster room first, just to illustrate a point. Let's make room 1 first, and then let's try and come back to the monster room. So let's make room 1 first. So it says here I want something called room 1. The variable name must be room 1, so it's obviously of type room. So just an empty variable here of a class type that will soon at some point become an object. And the name of the room should be first room. The blue door room should be the monster room, and the red door room should be room 2. Okay, so I can say new room. And I know that I have this constructor inside room that accepts a name. Blue door room, red door room contains monster in its final room. So I know I can pass the name of the room, which is fine. So this is called, at least in my brief, the first room. And now I hit a problem, right? Because I want to use the supplied monster room. Okay, so that's one issue. And another issue is supplying the red door room, right? Because the red door room doesn't yet exist. So the point I'm going to make here, and I'll make again as I go forward trying to do this, is that we've already seen these restrictions coming from our constructor, right? So while constructors are useful in the fact that they reassure or assure, ensure even, that certain values will be present. So here we can see that we always know we're going to have to pass some blue door room object or some red door room object to our room, so we always know there'll be some connections, and we won't end up with issues where rooms don't have connections, which might result in inconsistencies. At the same time, the constructors limit our flexibility. So in this assignment, we were actually perfectly fine for you not to use constructors. Again, you'd lose some of that assurance. So again, the assurance here would be assuming that you don't pass null or something like that to blue door room, red door room. The assurance would be that rooms were always connected. But we were happy for you to kind of remove the constructors and have less assurance, because there's a trade-off then between assurance and flexibility. Because while having this constructor would give you that assurance, it would stop you, or it would inhibit you from having the flexibility to declare your rooms in any order that you want, right? You'd want really to declare these in a certain order, so that you can have this, or you'd have to declare them in a certain order so that you can adhere to the restrictions of the constructor. Okay, so we were actually happy for you to have no constructors. So I'm going to look at a kind of different few things that we can do. So the first restriction here is that I need a monster room, right? So and this needs to obviously be declared before the first room, right? Because this needs a reference to the monster room. So I'm going to have to say room, monster room above it. I'm going to have to say new room. It's called the monster room. Okay. But again, now I hit a problem, right? Because this constructor tells me that I have to have a connected blue door room and red door room, because it's trying to account for this fact that we don't want any disconnected rooms, because then we might have an error in our game whereby a player tries to move to a non-existent room. This is actually a limitation that we're okay with for this assignment, because we hadn't yet looked at how to check null values, which would stop this being an issue. So what we can do instead is we could actually look at defining a second constructor and see what happens here. So we could say public room, and this is going to be a constructor that allows us to account for the monster room, right? So the monster room has, rather than having the 2, 4, 5 parameters here, it only has 3. It doesn't have a connected blue door room and a red door room. Instead, it just has, whether it contains a monster and its name, effectively. So 2 parameters here. And as I'll say again, if we have this second constructor, obviously it allows us to construct a class without connecting doors, which may feel like it's more error prone. But again, this was a limitation we were okay with, because we hadn't yet looked at checking for null, which is what you would do here, assuming it is possible to have empty values in connected rooms or unconnected rooms. So this was fine to have this second constructor, or indeed no constructors at all, which I'll talk about in a second. So we have this second constructor, which is, we're going to think it's for the monster room. So again, this has a name, and here it's going to have this boolean for contains monster. And we're going to say this dot name equals name. I'm going to say this dot contains monster equals contains monster. So inside door maze game now, I should have the flexibility to now say true. So this contains a monster. And then here again now I can set the blue door room. So I think the first one was blue door room. So now I'm going to use the first constructor inside room, because I know that the first constructor allows me to define connected rooms that do have a connection, which in this case is room 1. So I'm going to pass monster room, because I'm told that the blue door room leads to the monster room. But again, now I come across this issue, right? Because I want to link to room 2. So I can kind of go back through this almost recursively, right? So now I can say, well, room 2 needs to be defined before room 1. Does that make sense? And then room 3 would need to be defined before room 2. And you could kind of loop going backwards and work out that everything was, or make sure everything was dependent on everything else. All right, so this was fine if you did this, if you relied on constructors, but just to strongly illustrate the point as to how it's actually okay sometimes to not use constructors, I'm not actually going to use constructors in this solution. I'm going to just, at least not for room, I'm going to give myself maximum flexibility by not forcing anything to be provided upon the creation of a room, and instead do this all through the setter, so you can see this flexibility. Again, you do lose, there is more of a risk without constructors because again, you lose this assurance that there are going to be values in fields that are there waiting to be accessed. But again, just to show you maximum flexibility and to show you this idea of the other extreme, so when we have no constructors as opposed to when we have lots of constructors, I'm going to leave my constructors out here entirely and I'm just going to go for a load of get and set methods instead. So I'm going to say public void set name, string name, and I'm going to say this.name is name. Say public void set blue door room. What we could do here, which would be quite nice, is to actually just say set contains monster equal to true, right? Because otherwise the default value is going to be false. So we could say this would give us a little bit of a shortcut. I think that would work. Let's just, we'll wait and see though. We might need to change that in the future. Set final room. And then again, I think we're fine from there. Okay, and I'll need to add some get methods eventually, but I'll do those as I go along. Alright, so now we have maximum flexibility and I can do these things really in any order that I want. So I could actually stick to the main focus of the brief, and actually let's put a single constructor in here just because we can put a string name just to make this a little shorter. So I'm actually going to say now who's Sting? Sounds like a singer. Okay. So now I can have this extra constructor in. So now I can actually do things in an order, and I can relax a bit about the strict order in which I use. So again, I suspect many of you have actually done multiple constructors and then been careful about the order. Absolutely fine. You could maybe even argue that gives you kind of a good trade-off between flexibility and assurance. As in assurance, there's going to be certain values in certain fields and a less chance of encountering null errors. But again, I'm just going to show you a solution which minimizes the constructors, just so you can see the extreme where we do everything through get and set, which will obviously be more prone to null errors, but as this isn't something that you would have been able to guard against given what we'd looked at when coursework 6 was released, this isn't too much of an issue. Again, remember, we're not looking for perfect solutions, we're just looking for what we can do given the knowledge that we already have. So now I can have the flexibility to define the monster room first. I can say the monster room. Then I have a ton of flexibility just to make all my other rooms. So room 1, it's going to be called the first room. Room 2, second room. Room 3, third room. Room 4, the fourth room, and then six of the things. Goodness me. Room 5, the fifth room, and then room 6, sixth room. Now I have the flexibility to go ahead and set certain things. So I could say monster room dot set. Final room, set monster room, because we know that's the monster room. I could say, what have I done? I'll set contains monster, and we could say room 6 dot set final room. Alright, and then I can go ahead underneath maybe and kind of link these rooms together really with maximum flexibility. So I can say room 1 dot set blue door room, because that's what I have in my brief. Blue door room is going to be the monster room. I say room 1 dot set red door room, because my red door room leads to room 2. I can say room 2 dot set blue door room equals room 3. So you can see how now I'm doing this in order. The code's actually way more readable. So again, that's another benefit of the flexibility that having no constructors or smaller constructors give us. We get this kind of more greater level of readability. But of course, again, there's a trade-off there with the assurance of your class. So monster room there, room 3, set blue door room, monster room, room 3.set red door room, room 4, and then room 4.set blue door room, monster room, 4.set red door room, room 5, and finally, I hope, room 5.set blue door room, room 6, and room 5.set red door room, monster room. Okay. Room 6 I've set to be the last room, and it's got its name already, so there we go. Alright, so a little bit more readable, a little bit more flexibility, but again a trade-off there. Because of course here someone could make rooms and try and move through them without there being any connected rooms. But as the monster room is not going to have any connected rooms anyway, and we hadn't yet looked at null to try and guard against this, this is an acceptable sort of limitation, and so flexibility wins out here. And we can try and run that just to make sure everything's working as we want. Okay, no errors or anything like that. That's fine. So I'm going to skip back now and look at the move functionality. So we know that a player can move to a supplied room, which will assume that the supplied room is one linked to, again, I've talked about that. The method returns a result stating if it was a choice or not. So the room may contain the monster, which will attack the player, resulting in the player losing a life. So effectively what we want to do is we want to supply a potential move room to our player, and they're going to basically tentatively then open that door, and they're going to look inside, and it'll either be the right way, in which that's great, they can move into that room, or it'll be the wrong way, and they will open the room. They won't go in, that's an important point, but the monster will come into their room and attack them or whatever, and they will lose a life. So the first thing we say is that the room may contain the monster. So with the supplied room, we need to test, does that contain the monster? Which means, of course, we need to now have a get method here. So get contains monster. And we want to return contains monster. So now here inside player, we say supplied room dot get contains monster. And we want to say, if it's the case that the supplied room contains monster, if that's true, then it says here that the player, the monster attacks the player and they will lose a life. So we can say lives minus minus. And then again, crucially here, we want to return false. And again, I'll talk about this a bit more in a minute, but it's nice to have this well-defined interface, this well-defined return from move for a couple of reasons. So if I forget to talk about this, it allows us to do printing inside the main, which we should try and do as much as possible. Again, there are the odd occasions where I'll contradict this, perhaps during the lectures, just for illustration purposes. But in general, we should try and do our printing in the main, because otherwise, if someone else uses our class, then they might get this output that they don't want, or they want to change it, and obviously it's hard to change it if it's wrapped inside one of our classes. Whereas if they just get a true-false value back, they can interpret that response and print something as they wish. So that's the reason we try and do printing in main. If we print in main, it also encourages us to return values more in general, which might involve returning objects, which gives us the ability to then use those objects somewhere else, so it makes our program more extensible. And again, a more subtle idea is if there was an AI playing this game, then having a Boolean result or any kind of result from a move method here would be better, because it would allow the AI to interpret this more easily, whereas if it's a void return and there's simply something printed to the terminal, it's harder for the AI to interpret that. Some people return strings from this method. That was fine. Wouldn't lose any marks there. I think it's a reasonable interpretation that this method returns a result stating if the supplied room is correct or not. That could be interpreted as a string or a Boolean. But the absolute best result here is Boolean, I think, because it's, again, for this AI reason, easier to interpret in that way. But again, absolutely fine if you returned a string here. I'll try and talk about that again, or at least summarize that again later, but I may forget. Okay, so if the supplied room contains get monster, then we're going to reduce the lives and return false. Importantly, we're not going to move into the next room, so we can't ever, if we can't go into the monster's room, the monster's in there, it would just kill us again. Well, that's a bit graphic, hurt us again. And of course, there's no way out of the monster room effectively, because you can't go back through the door from which you came. We don't model that. We just have a red and blue door. And of course, if we look at the monster room here, then we never set the red and blue door, okay? So we can't go into the monster room. We should never go in there because we can't get out again. I saw a couple of people having errors with this. So this is the only thing we want to do inside. If there's a monster, we want to just deduct the lives and then return false. And here you see, I suppose some people probably did this inside door maze game. I think it's good to put this logic inside player because it wraps up the functionality nicely inside this method. It has a clear purpose to move the player and a clear result, which is that was successful or not. So it makes sense that the actual move check and the logic should be inside move as well. Second bullet point of 3 says, otherwise the room is the correct choice and the player should be moved into the room. So this was quite a subtle idea that I think some people, perhaps was the difficult part of this assignment, was to imagine how the player actually moves through the room. It's quite simple. If the player is in one room, so imagine they're inside room 1, then the value inside the player's current room field is going to be room 1, right? So there'll be a room 1 object inside the player's current room field. Inside that room 1 object, because we've talked about it already, there will be room 2, right? So perhaps I should have talked about this a bit more as I was typing it. So we can imagine that room 2 is now nested, because remember when we pass objects inside each other, they effectively nest inside them. It's like the 3 types of question nested inside an exam in coursework 4, I think it was. Yeah, coursework 4. And so here the same principle is the same. So room 2 nests inside room 1, having priorly, nested room 3 inside room 2. So you can see we get this like nesting process. So each time we effectively examine what's in the next nested object, it kind of represents us moving through the rooms. Okay, so let me expand on that a bit. So let's imagine we're inside, as I say, player, and the player's current value inside current room is a room 1 object. Then we know if we say to that room object what's inside your, so what was the connection here? So what's inside your red door, what's inside your red door room field, we're going to get room 2. So if we now know that we can, from inside player, using current room or what's inside current room, which will be a room 1 object, we can ask that current room object what's in your red door room field, which would be a room 2 object. So we get this room 2 object back, we get this reference to the next room we need to be in, so we simply need to update our current room field to be that new room. For those of you who are familiar with linked list, this is effectively a form of linked list, because each room has a kind of reference or knows about the next room in the list. So if we want to move through that list of rooms, or if we want to move through a kind of abstract linked list structure, then we obviously just ask the current item in the list, what are you connected to? Okay, so this is the general idea. So there's no need to do, or there will be no need for us to do, when we talk about the actual loop functionality that we're going to put in here, there'll be no need for us to have individual cases for depending on which room we're in. We instead abstract and generalize this process such that a movement simply involves finding out what the next room is from the current supplied room. So all I need to do is I'll say whatever my supplied room is. We're going to say get your red door room field, which we know is, we need to add an accessor method for that. So where's so public void get red door room. Okay, so if supplied room dot get contains monster, then we don't do that. And actually, let's do the check elsewhere because I think that would be simpler. So it's even simpler than that. We'll do the check for red and blue somewhere else. We're going to say current room equals supplied room. All right. So yeah, I was jumping ahead there and overcomplicating because of the simplicity here inside our move method. All we need to say is, and this makes sense, right? So if the supplied room contains the monster, then deduct the lives. Otherwise, it's perfectly fine for us to update our room to be that supplied room. Okay, so we're going to say current room equals supplied room and then return true. Okay, so let me say that again. So I jumped ahead a little bit. We don't actually need to yet think about red or blue door rooms, at least in the implementation I had kind of lurking in my mind for this week. We're not going to jump ahead there and look at red and blue door rooms. We're actually simply going to say if a user supplies us a room and it's fine to move into that room because there isn't a monster in it, then simply update the current room to be the supplied room. So that makes sense in terms of what I was saying before. So if you're in room 1 and you supply room 2, you're going to move to room 2. If you're in room 2 and you supply room 3, you're going to move to room 3, 3 to 4, etc., etc., etc. Which is why we have this little disclaimer statement that says we will assume that the supplied room is always one that's linked to the player's current room. So that's the idea there. So I'm sure some of you will have actually done inside player, inside the move, you will have done the logic for the red or blue door rooms here. Again, not a problem. But I'm just going to put it inside, or shouldn't be a problem at least. It's worth saying that what I say offhand in this video, which may seem to relate to marks, is only finalized once we put those marks out. So don't freak out or anything like that, or take it like this. So that should be fine to either how it suggests or work out the red or blue door connections inside move. But again, this is only formalized once we get the marks back. Okay, so of course there are a variety of solutions that we accept. But of course, the reason you should be using these videos is to compare them to what you've done, and if there are any gross departures from this model solution, then you should think about perhaps evolving your coding style, of course, subject to the discussion with a TA. Okay, so the point to make is these videos are to show you the solution, they are to kind of show you the style of coding that we're looking for, but if your solution is slightly different, that's fine. It's really sort of radical departures from good coding practice that we're looking for and that you should be looking for, especially if you're watching this video to understand a mark. So for example, I might have not had private there. Rather than supplying a room here, I could have had something else. You know, I could have put an int here or whatever. These are kind of little mistakes that we want you to check for and understand why they should be in a certain way. But of course, again, as I say, the general solution, we're more kind of flexible on that. Okay, so I'm going to go for a kind of simplified move method here that simply takes the supplied room, and if it doesn't contain the monster, then we move the player to that room. Which is, I guess, kind of what the brief was leading you towards here, given this disclaimer that we're only going to supply a connected room. All right, so I've done 2.1 already, so that was what I just did now was 1.3. So now I've done 2.1. Everything's linked up. So now I can go to 2.2, which says create a player and give them a maximum number of lives and start them off in room 1. So I can say player equals new player. And again here, right? So I had this quite strict constructor, but reading ahead, I know that I'm going to need to actually set the player's name later on, so I actually can't have that in the constructor. Again, this assignment was showing you how constructors aren't always fit for purpose. So set name here, I know I'm going to need a future name. Okay. So it's probably also worth saying that I know lots of you follow these videos and kind of type along, which is great. Of course, if I come back and change things or spot errors as I did in the last one, that might be a bit frustrating. But of course, these videos are supposed to serve multiple purposes. So first of all, they are for you to type along and get the model solution. They're also to show you concepts and kind of give you an insight into alternate solutions. So they won't always be sequential, they mainly will be. But for those of you who are typing along, be aware that I will come back and change things. And therefore you should watch the whole video really right to the end and change things as you need. So they are designed to show you the model solution, but also go that little bit further, show you alternate solutions, how things should and shouldn't be done. Player equals new player. Now I've changed this restriction, so I know I need to give them a maximum of 2 lives and start them off in room 1. Okay, this is fine to put through the constructor. Okay, so I know that the name, because I've just read ahead, I know that the name is coming later. So create a main game using the following guidelines. The game should first output an introductory message to the user informing them of the game rules. I saw some really, really awesome messages that people were doing. Loads of really nice ASCII art and stuff like that. That's awesome. It's great to see you engaging with the assignments in this way. So introductory message. So you would have put something more elaborate here. I'm just going to say welcome. You know what to do, because you guys will have known these rules back to front now, I'm sure. And then it says ask the user to input their name and update the player's name in the game accordingly. So along with looking at the other extreme where we don't use constructors or only use them in a minimal way, part of this assignment was testing your use of scanner, right, which was the main thing that we covered in the lecture prior to this assignment being released. And scanners offer us the ability to have user input. So in the assignment it says ask the user to input their name and update the player's name in the game accordingly. So we know we need a scanner. And we know from the notes that what we're doing here is we're making an object of a class, not our class, but a library class, and we know from looking at the documentation that's what's required here is a link to the system import, which is either from the terminal or down here if you're using an IDE. And we know this, as I say, from the documentation, and we now know from the most recent lecture that this is a public static final field inside the system class, which allows us to grab and access the input stream in a sensible way. We can't change it because it's final. We can access it through the class because it's static. So it's public. It's public. It can be public because it's also static and final. Remember, that's our rule of thumb. So we know what system.in does here. But even if we didn't, we'd be able to discern that from the API. Of course, I need to import scanner. It's a little trick here in Eclipse to import things quickly. I think it's Shift Command O, but again, shouldn't be using IDEs. And of course, we now know, and you would know this from the documentation, even if you didn't have the IDE to help you, that this scanner is inside the Java utility package, so java.util.scanner. We'll talk about again what the dots and the term package mean next semester. So you'd know that from the documentation, you'd know the import, it was in the notes if nothing else. And again, we now know that we've made this object, we've adhered to the constructor, so we can now access and interact with its fields. So if we want to get a string from the user, we have a couple of options. I saw people doing next string. Inventive, quite I guess quite intuitive that. But again, remember, this has to be a method that exists inside the string class, inside the scanner class. So if you find yourself writing methods like this and them not working or not being found, then that's probably because they don't exist in the library class. So it's up to you to kind of go to the docs and think about which methods are good for my purposes. So to go over to scanner and find out, well, this is what I need. So let's actually see if we can I do this just to show you? It's a new window here. We want to say Google, no, we want to say scanner Java. So if you ever want a library class, simply write, or some documentation of a library class, simply write it into Google. I'm not telling you to Google answers or anything, it's just a quick way to get to the API. So here we can see, I've got scanner here, right? So here we see I've got a list of constructors and a list of methods, and I can see if I were to look for next string that there would be no next string method here if I were to go through. What we do have is just next, which will get a token, and I know that returns a string, so that would be nice as well. And I have something called next line as well, which would take me the whole line of input that I had. Both next and next line I think are valid ways to get input. Next line would take a whole line, so all the tokens in a line, even if they have spaces. Whereas next would just take individual tokens. If you want to remind yourself of the differences there, and obviously read up on those methods and think about or review in the notes what a token actually means. So here we can say, I'm going to go with just next. So I know that's going to take one token of user input from the command line. It's going to stop and pause and wait for me to write something that I can then return. Okay, so the utility of this method, what it does for us, what it brings us, what it gives us, is the ability to stop and wait, assuming there are no tokens waiting in the buffer, and will input something for us. So if we were to write enter your name, and then we were to do something like player.setName in.next, then what we're doing here effectively, as in.next is just a method call, no matter whether it kind of stops the program and waits for input or not, this is going to return a string, so I can just grab this as the result of the method call and put it inside my player here by sending it directly to this set or this mutator method. Okay. So we've got this warning here, which tells me that what it wants me to do is in.close. But again, remember, if you look at the slides, there are some implications for doing this, because if you close this scanner, then you'll also close system.in. That's just the way that close works, which might not be the behavior that you want. You might want them to reopen a scanner at some point in the future, which will be difficult for you if it's already closed. Okay, so this is optional. I'll leave it in there for now, but you wouldn't lose marks or anything like that if you didn't put it in, because again, there's this optional use of this close method. Let's give this a run and see what happens. Welcome, you know what to do, and it says enter your name, and you can see here this little stop shows me that my program's still running. If you see this in an IDE, when you use it in the future, that means that your program's still running, so it's either stuck in some kind of loop or it's waiting for you to do something. So I can write Martin, and then I know my program ends because that's the last thing it did was to set the player's name. Okay, so let's add a little get method inside here just to show that that input's actually getting stored. Get name, return name. Inside my .names game I can say system.out.println player.getName. So I can just remind myself that this is actually working. So Martin, then it prints Martin. Okay, so this is again something else that the assignment was encouraging you to look at. It was to make objects of a library class, which is scanner, adhere to the rules in the constructor, whether we understand them or not. It's okay not to understand them because we have the nice documentation, and the classes themselves provide this abstraction over the functionality. That is, we don't really care what's going on inside Next, we just know that it has this interface and performs this functionality for us. We can look at it if we want to. So we create this in object. We know that as soon as it's called, it's going to wait, so usually we put some kind of notice to the user, because otherwise if we were just to run it, then it would just be hanging and the user wouldn't be quite sure what was going on. So we usually preempt this kind of waiting for input with some explanation or some warning that it's going to ask for input. So welcome, you know what to do, enter your name, and then my name, we'll put that in there, and again, as I've showed you already, it prints it out. Okay, so taking and storing this input and then getting it back. But we don't want to print it out straight away, that's not what we're asked to do. So the next point in 3 says, next, repeatedly present the status of the game to the user, including the player's name, lives left, and details of the current room. It should also repeatedly ask the user to input their choice of door, either blue or red. Make the player move to the selected room. Any other input from the user should result in a message being output stating the acceptable commands they can enter, along with their meaning. So we know we need some kind of loop, and it might not be immediately clear what is going on in that loop, or what's going to control the iterations of that loop. So what I like to do in these scenarios where I kind of want to delay thinking about how I'm going to end my loop, or I just want to kind of get the loop kind of fleshed out without thinking about when it's going to end, is I like to use an infinite loop. So I can say while true. This will go on forever, and it will just allow me to get that understanding that I've got the right number or the right type of iterations going first, I've got the right functionality inside my loop, and then later on I can think about, well, how do I end this loop? So again, this is something that would be in the noughts and crosses example if you take a look at that. Not something you were expected to have looked at for this assignment, but just going forward, of course you didn't need to know about while true for this assignment. This is just my own way of approaching the development of a solution. But again, as you'll see in the noughts and crosses, if you look at that, I also apply that approach here. I start with an infinite loop, and then think about, well, what values can I get inside that loop that might allow me to change how the loop progresses. Okay, so this won't be part of the final solution. Again, if you're following this sequentially, you're going to have to go backwards and forwards a bit, but actually maybe that's hopefully a useful process for you. So I know that I'm going to have this loop. I'm delaying thinking about when it's going to end. I just want to think about the iterations themselves. So I'm told to print the certain details to the user, the player's name. So we just did that before, so we can say your name or something like that. Again, maybe this might have seemed a little not pointless, but perhaps strange that you give the player their name when they know it already. But it's just about printing relevant bits of status information to the user, right? So this is the name you've given us. This is your character name or player name or whatever. So we could say something like game status, just to put this printing of the player's name in some context. Your name, lives left, and I'm going to, of course, need another accessor here. So we'll say player dot. Where's a logical place to put this? Let's put it here. Get lives. We can return lives left. Oh, it's just lives, isn't it? And then get lives. And then the final thing is system.out.println current room. This accessor. Okay, so I'm going to now just return rather than returning a primitive, or so an int here, we return a sort of a string here, which is of course of a class type. It's an object that behaves like a primitive, and then of course we've got a true class type here that's returned. Mistake here that I saw a couple of people making, and again it's one that we'll cover or is covered in the noughts and crosses example, and again I think I talked about this in a hints and tips video. The idea here is that which we wouldn't expect you to do is to actually try and print objects directly. So let's see what happens if we do this. This is actually going to go on forever, isn't it? So I'm going to use this break here, which again it's just temporary. And of course we obviously usually encourage or discourage you even from using break because it's a sort of contentious control command. So if I play this now and I say Martin, it's actually going to be really annoying to keep asking my name. So I'm actually going to comment this out for now. I can say, well, I'll leave the scanner there. I'm going to need that again, aren't I? So I'm going to say like this. And again, for those of you that are following along, I'm going to say to be put back in. Actually, a good thing to do if you are following this video and typing is to actually watch the whole thing first and then try and write it from memory. That would actually be an even better way of doing it. But of course, here you can see we've got this strange output. So I don't know why I put a plus in there. We've got your name, Martin, lives left 2, and we've got this strange room art and then some kind of hex value. What we're doing here is, as you can see, which is unexpected, is to actually try and print an object directly, which we can't do. What's nicer, and again what we can look at in the noughts and crosses example, but again wasn't needed for this assignment, is to try and make an object directly printable, but again we've not looked at how to do that, so there's no expectation to do this. Instead the expectation is that you'd then say current room.getName, of course, which I need to define, so we can say public string current room, get name, which will return me the name of that room. Okay, so I've got this get name here. So again, printing this out would give you this odd functionality. You'd get this strange output here, which I'll talk about in the context of noughts and crosses. But again, this wasn't something you were expected to do. We've never looked at printing objects directly, so we wouldn't have expected you to do that. Instead, we're going to, obviously this returns an object, so we can then go ahead and call a method on that returned object. And this kind of sequence of method calls to access returned objects is something that we've seen quite a few times now. So now we get the expected output, so the current room is the first room, which is good because that's where the player starts. Okay, so we can see this, we've got a nice one run of our loop. We're breaking here just temporarily, so we can suspend our use of or trying to control when this loop ends. And I've got this to be put back in because it saves me, it's easier for me to test. These are all steps that you can take just to speed up your development process, just to look at really making an incremental solution. 3.3, the third bullet point, at least says next repeatedly present the states of the game, which we've done. And the user should also be repeatedly asked for their input, or to input their choice of door, either blue or red. So we need to say something like system.out.println, what is your choice of door? And then we need to somehow take that choice, don't we? So we need to say, again, using the same syntax that we did here, we want to say string door choice equals in.next. So we're going to say, what's your choice of door? And the user's going to enter something like red, and then we'll do something. And obviously, just for now, it ends. Oh, they're going to say something like blue, in which case it will do something. But of course, now it just ends. What we want to do is, as the assignment says, we want to make the player, or try and make the player move to the selected room, which might be the right room for their path or might be wrong and they might hit the monster. Okay, this is the functionality we've already kind of built in with this move method. So we want to say if, we want to obviously examine what's inside this door choice string. We want to say if door choice ember.equals, we never test strings with kind of this equality operator. We always use the method.equals for reasons that I've described. Sometimes it will return the right result, but it's unpredictable in that respect, so we should always avoid it. So if we say door choice.equals red, then we obviously want to try and move to the red room. Else if door choice.equals blue, then we want to try and move to the blue room. And then in any other case, if the user enters anything else, we're just going to say system.out.println something like sorry, your input was not recognized. And of course, this is what it says here. So it says any other input from the user should result in a message being output stating that they accept what commands they can enter along with their meaning. Fine. So we could say please enter red or blue. Red. I think what it means by acceptable meaning is please enter red to go to the red room, or blue to go to the blue room. Yeah, so I appreciate that it's not good when you're following along for it to go off the screen like this, but hopefully you can remember what that says. So sorry, your input was not recognized, and you can just, really, it's just any string here to prompt the user. So some string that prompts the user, tells them their input wasn't recognized, tells them red and blue, and reminds them of what these commands mean. I mean, you could, I guess, separate this out. So going back to the top of the loop here, you could remind them that this is enter blue or red. Yeah, so you could interpret that this way. So rather than having this down here, which in fact I think I'm going to do just to make things short, input not recognized. Of course, if this isn't recognized and we're looping multiple times, then you're just now going to go back to the top of the loop and you'll remind the user of the acceptable commands anyway, right? So you could say your input was not recognized, go back to the top of the loop and remind them again what blue or red means, okay, which I think would fulfill this fine. Or you could put it at the bottom as I did initially, that's fine too. Right, so we have door choice equals red or blue. Let me just switch this around because I think in my setup at least it's blue then followed by red, so that just keeps things a little consistent. A couple of things to mention here. So you can't avoid this choice, this use of the temporary variable. You can't write in.next here, and you couldn't write in.next here again. Because think about it, if we get to this statement, we get to this if statement, and the program will pause. It will say, so we could say system.out.println, you entered blue. We could say system.out.println, you entered red. And while this might seem fine, this might seem innocent. Let's see what happens if we run it. So if I write blue, it's fine, finishes, that's what we've got so far. But if I write red, then nothing happens, right? Because what's happened is you've gone to this first if, you've stopped for next. So what I've entered here is actually it for this this next call here, and it's been checked with blue. And that's failed, obviously, so this evaluates to false, so we don't go inside here. And obviously, if an if evaluates to false, then we go to the next clause, so to speak, that connects these blocks here. And so now we call next again, right? So which is why it's pausing again, and I would now have to enter red for it to say you entered red. So this isn't really the desired functionality, so this is one of the cases in which we can't really get around having a temporary variable. So in general, I like to avoid temporary variables if I can. Nothing too wrong about using them. Some would argue that it's better for memory anyway, but I think the impact there is negligible from storing things temporarily. So I tend to recall methods. Again, it's just up to the style that you develop there. But here there's one place in which we can't really get around it, at least not in a simple way. So door choice equals next in, and we're going to test that. You could be inventive with your equals here. So we could say door choice. I know I showed this in the notes. We could say to lowercase. So what we do is we account for our program's more robust. So if someone enters blue in all capital, or they have a mix of upper and lowercase, then anything they enter will be first changed to lowercase before it's tested to be equal to the value in all lowercase, right? So anything you enter, if it was blue with a capital B, would be transformed by this to blue with a lowercase b, so then this equals would succeed, right? Because obviously it would be case sensitive. So we use this to lowercase. Some people used equals ignore case. That was fine. I'm just going to leave it as to lowercase for now to make it consistent with the notes. Right, so now we want to say if the user enters blue, then we want to move them to the blue room, don't we? And we've already handily set up a way to do this because we've got simply our move method. Oh, it's definitely not in room, inside player, that's ready to receive the supplied room. So we want to say player, if they enter the blue room, we want to move them to, again, this is probably the trickiest part of the assignment, we want to remove them to wherever they are now. Remember I talked about this briefly before. We want to open up the blue door, we want to find what's stored in the blue door field, and we want to try and move them to that room. Right, so we need to say player.getCurrentRoom.get, and I think I might have left this out before, so I'm going to add it in now. We're going to say public room get blue door room, and we're going to say, what's it called, blue door room? Oh no, goodness, of course it's inside the room class, isn't it? Yeah, and this. Of course, it wouldn't be inside player because the player doesn't know it's connected rooms. The room does, doesn't it? So yeah, apologies for that. So room just proof that these are indeed live. Get red door room, return red door room. And so now we can know, of course, this, as I say, this wouldn't be methods inside player, they'd be inside room. So it's the room itself, as we know from the fields, that knows which rooms are connected to it. So if I want the player to move to a connected room, then I first have to understand which room they're in now. So effectively, let's look at where they are now. And then we need to look at which room is connected via the blue door, right? So what's going to happen here? Let's imagine we're in room 1. And we know that what's connected via the blue door is the monster room, right? So we're going to try and therefore we would look at the fields of room 1. So we look at room 1 and we know that inside the blue door field is the monster room. So we're going to say, right, go to my player, ask them what their current room is, which will be room 1, and then ask them what's inside their blue door room field, which I know because I've set it up here as the monster room. So what this is going to return is the monster room, right? Because the value inside room 1, which is the player's current room, because we set it up here, the value inside room 1, inside the blue door room field is the monster room. That's what I'm saying here, right? I'm saying player, get their current room, which is room 1, get what's inside the blue door room field, which is the monster room, take that all and put it back inside, pass it to player.move. Okay, so this will return the monster room because the thing connected to the current room, which is room 1, is the monster room. So we're going to try and move the player to the monster room. That makes sense. And importantly, now we want to look at the result of doing that. So a good thing to do when you're programming, I think I mentioned this quite early on, is to just write out a natural solution, that what feels naturally to you at first, and then come back and try and refine it later. So again, for those that are following, I'm going to just, again, this is just from my mind, most of these solutions are. So I'm going to write a solution and then potentially come along and refine it later. So first of all, I know that my move returns a Boolean, doesn't it? So my move here returns a Boolean indicating whether the move has been successful or not. So I can say if this is successful, I can say system.out.println moved to, and I can say player.getCurrentRoom.getName, right? So I can say, now I know that the player's moved to the room, so if this is true, so if this evaluates to true, so remember again what we're doing, we're saying go to the current room, which in the first case will be room 1, find what's behind the blue door, because it's stored in the blue door room field of room. If it's equal to the monster room, then the player will move to the monster room, or we will attempt to move the player to the monster room, but of course they can't move there. So I'm going to lose lives and return false. So this will be evaluated to false. But let's imagine that behind the blue door room we did have a room that we could progress to, then we'd say, actually, we'd come in here inside move. There wouldn't be a monster inside the room, so they would go inside the current room. Okay, so I'll test that out. We'll test this out in a second, don't you worry. Okay, so if it's successful, so if this returns true, then they move to, and otherwise we say, uh-oh, found a monster, new lives, because player.getLives. All right, so let's see let's test this functionality out. So we run things here, we're given this introduction for our game, so welcome, you know what to do, game status, your name, oh, what's going on here? Oh, because I never set the name, did I? So we can say player.setName Martin, so let me always be Martin. Okay, so it'll always be Martin rather than having to input it, your name Martin. Again, remember what I did here, so because it was annoying me having to always enter my name, I took it out, but of course that left an empty field for name, so now I'm just going to manually set it, and I'll put this back in later on. So welcome, your name Martin, live left 2, current room, the first room, enter blue or red. Right, so I'm here. Well, it was when I printed this out, and now I'm here, so I'm at door choice. So if I enter blue, then what I'm going to try and do is I'm in room 1 now. I'm going to look behind the blue door of room 1, which I know is monster room. I'm going to look at the nested object inside my room 1 object, inside the blue door room field, and I'm going to try and move my player there. So I try and move my player there. I'm going to take supplied room, which in this case, the result of this, which is the monster room. I'm going to try and move my player in there. This is obviously going to return true because it's the monster room, and deduct my lives and return false. So if this whole thing returns false, I won't evaluate the top bit here, I'll instead evaluate the bottom bit down here. So what happens if I type blue? Uh-oh, found a monster, new lives 1. Okay, so this is probably the biggest bit of complexity. We're testing the result of moving the player here, and obviously it's false because we know behind the blue door there's a monster room. There's the monster room, which contains the monster. We know we can't move into that. Instead, as we would down here, instead we satisfy the top if clause here. We reduce lives, return false, and we can use this to inform our printing. So remember, coming back to this point about printing inside move, we don't want to do that. Instead, we want to print inside the main method for the reasons that I mentioned before. Or indeed return a string and print that. That was another valid option. Alright, so now it's the same for the red door. And I'm going to type this out because you know how notorious I am for typos. We're going to say player.get current room. And this time, because they want to move through the red door, we say get red door room. Yeah. And we then do exactly the same thing. So if that works, then we know that they've moved room. Otherwise, we're going to say, uh-oh, found monster, and they're going to lose a life. Okay, so if they move to the blue door room, we first test, is that move possible, which is effectively what the true or false returns from, or has it happened, which is effectively what's returned from move here. If it has happened, we'll inform the user. If it hasn't, we'll inform them that they've lost a life, and the same for red, right? If we're able to move through to the door that's connected to the red door room, we'll print that we've moved there. Otherwise, we'll print that we've lost a life because of the monster. So as we can see here, the value inside the red door room field of room 1, so the nested object here is room 2, which is a valid room. So if I enter red here, I'm going to be able to satisfy this top if statement, and I'm going to actually move into the red room, right? So I'm going to try this again. And of course, as before, if I enter blue, I lose a life because that was the wrong choice. There was a monster behind the door of the first room. But if I enter red, everything's fine and I can move to the second room. Makes sense? Excellent. Okay, so now we want to kind of see this this loop running for a couple of iterations. Okay, so what I'd say is if you want to gradually change your loop now from an infinite loop to an actual loop that's going to run for a number of iterations that's appropriate, I would change it to a for loop. So rather than going straight ahead with a while loop, because they're quite hard to debug, and I'd say int I equals 0, I is less than 10, I plus plus. So we can just try 10 iterations here going through our program just to see what's going on. So I'll then remove my break and we'll try it again. Okay, so now we know we're going to get 10 iterations, probably a bit too many, but I just want to see how's my program running, how does it work from step to step. Okay, so now I can run my program. Again, I get this greeting. So I can cheat a little and think about what the right steps are, okay, which is what I'm going to do. So now I know I'm in room 1 because it says I'm current room, first room. And I know that the correct choice is to go through the red door, right? Because I know that the connected object is room 2. So if I type red, great. So now it says move to the second room. Now I come back to the top of the loop. I'm on my second iteration, and I can see that there's a new status, there's a new state to my player, right? Because now rather than him being in the first room, he's in the second room. See, so we're progressing through the game. We're using these links that we've created between the rooms by nesting these rooms inside each other. We're using these links to actually progress conceptually, I guess, through our game. So now I'm in the second room, and I know what's connected to the second room or at least the right room that's connected to the second room is the blue door room. So I could enter blue here, and now I'm in the third room, you see, so this is just progressing nicely. No different checks for the rooms. All I'm doing is I'm relying on where the player is now. I'm relying on updating state rather than on a series of conditionals to work out where to move, right? So now I'm in the third room, and I know what's connected to the third room is the fourth room via the red door, so I can write red. Now I'm in the fourth room, and then I'm in room 4, so now I can move to room 5, so I know that's red again, and so I'm in the fifth room, and you can see it progressing here now, right? So there are a couple of different ways to keep looping. Yeah, and let's think about why we want to keep looping in this way. Right? I mean, I think this was probably quite intuitive to lots of you. I saw lots of people getting this successfully, which is great. One of the ways we could do it, which was probably most popular, is we want to keep looping under 2 circumstances. The first circumstance is that the player is not in their final room. Because so long as they're not in the final room, we want to keep prompting them to move onwards. So while they're not in this 6th room, we want them to keep going forward, don't we? So one of the reasons that one of the kind of conditions for keeping going around the loop is that the player is not in their final room. So we want to say, of course, we want to now change this to a while player dot get current room, not get cast, dot get current room, dot is final room, right? So I'm going to need to add another method here. I'll actually just call it get final room. If I could spell Boolean, that would help. Get final room. It's going to return is final room. So we want to keep looping while it's the case that the player is not in their final room. So get current room dot get final room not equal to true. So we want to keep going around the loop while this is true. All right, so again, incremental testing. Let's test this out to see what's going on, see if we can actually progress through our rooms now in the right way. So again, I'm going to cheat because I know the ordering of the rooms. I can see them here. So if I'm in room 1 and I want to move to room 2, I need to go through the red door. If I'm in room 2 and I want to move to room 3, then I have to go to the red door again. Oh, no, that's not right. Hang on, what did I do? Oh no, I can't play my own game. Let's try this again. So room 1, I want to go through the red door. Of course, yeah, I misread it. So now I need to go through the blue door. Room 3, I want to go through the red door. Room 4, I want to go through the red door again. Then the 5th room, I want to go through to the final room, right? And the final room is connected by the blue door, so I write blue. And here you can see my program ends, right? So this is good. This is, you know, we just keep looping while I'm not in the final room. Okay, so effectively here now I've finished the game, I've completed the game, and everything's great. So what I could actually do now is after the loop's ended, so down here I could say finished the game. All right? Yeah. Okay. But there's another issue, right? So we only want to allow the player to keep playing while it's the case that they have lives. Okay, so there needs to be another joining condition here, and it's not an or because these are both things. If one fails, then the whole loop should fail. Remember, this is the idea of short circuit evaluation, or the very nature of this conditional operator. So we need them both to be. If one of them is violated, we want the whole loop to end. So these both need to be true in order for the or player to continue playing the game. So it needs to both be the case that the player's not in the final room, and it also needs to be the case that the player's lives are greater than 0, right? Because if the player's lives fall below 0, then they will not be allowed to play anymore because they've encountered the monster too many times. All right. So let me say that again. So we're going to keep looping while it's the case that they're not in the final room, so while this returns true, and while it's the case that their lives are greater than 0, which should also return true for the game to continue. And we use the AND here because if either of these is false, it will actually just be the first one. Because of short circuit evaluation, we'll never evaluate this. So once this returns false, of course, that's enough for the game to end it. You know, the lives aren't important, so we go ahead and end the game there. Okay, and I guess just to represent the precedence of this operator over the other, I'll put the AND there, but I don't think that will make too much difference there. But just to make sure, we're going to put the lives first because it's obviously more, I think, more important. Okay. Right. Great. Let's run this now and see what happens. So we've tested now that this second condition for not being in the final room. Let's test now this condition for the lives being greater than 0. Let's see what happens if we make some mistakes. So we're in the first room, and I know that room 1 is connected to room 2 via the red door. So if I write blue, I know the monster's going to get me. And this will actually also allow us to see the nice way that we've structured our solution and what happens. So if I write blue, I enter the monster room and I lose a life. And you can see now I loop right back up to the start of the loop. And this is nice because we get another chance now. We get another chance to select the right door. So it's almost a game of trial and error. So people are asking, well, what's the point in having the chance again? Well, that's the whole point of the game. It's trial and error. The player works out where they can and can't go, and hopefully learns, and thus there's a challenge to the game. There's this memory element to it as they try and progress through the doors. So in order to model the fact that the monster's got the player, we don't really need to do anything else but allow the loop to come back to the top. So here, if I enter blue, then I'm going to satisfy the second statement here. I deduct a life, and then everything else just kind of ends, and we come back to the top of the loop. Okay, we can now see that the that the player is now on 1 life. Okay, so they're in the same place, unlike when a move is successful and we actually change room here. When a move is unsuccessful, as we know, when the move is unsuccessful, we don't update the current room field, so effectively the player stays in the same place. So what happens now, again, if I enter the same bad decision, so, I don't know, playing the game drunk or whatever, I enter blue, and now you see finish the game. Okay, so I only have these 2 lives. This is the issue here, in that I have a finite number of guesses or chances to get things right. Okay, excellent. One last thing for us to do, and then I guess I'll try and tidy things up a little bit, is we need something here, right? So there are 2 ways in which we can finish the game, either because we've got into the final room or because we've perished because the monster's got us. And so we don't just want to write a generic finish the game, we need to let them know what's actually happened. So this is the last 2 points of the assignment. So ensure that when the player's lives reach 0, they lose the game, which we've done, and ensure that when the player reaches the final room, they win the game. So it's kind of this implicit idea that we should tell them what's happened. So we can say if player.get current room .get final room equals true. So if it's the case that when we drop out of this loop, the player's in the final room because we violated this second statement, then we know that they've won the game. But if it's the case that they drop out of the loop for any other reason, which can only be that they've lost lives, then we can say lost the game. Makes sense? Good. So let's again always incrementally test, see what's going on here. So let's see. So if I enter blue and then blue, I lost the game. Uh-oh. So that's right, whenever print statements are working right in that sense. And now I want to say, I actually want to go through the right path. So again, I'll know this off by heart by the end. Red, and then blue, and then red again, and then finally blue. Yay, finished. All right. Okay, that looks good to me. There are some slight optimizations we could make, so we've got a little bit of repetition here. We could say have a temporary variable here. So let's just try this out. Again, this is just off the top of my head, so let's see what happens. Hopefully it should work, at least in the second that I came up with it might. So we could say something like result here. And then we can say that the result here, let's just take this out and put this at the bottom like this. And we could say that the result here is, we can then say equal to whatever the outcome is here. So we could say result equals player.move. So we could actually now take that out. And then here we could say same thing here, result equals the result of trying to move to the red door room. Okay. And then down here, rather than, we could say if result, so if that's true, then do this. And let's give this a default value. Then we say, uh-oh, found a monster. Now, this is going to be problematic, isn't it? Because it's going to be difficult to differentiate between when the user has entered something wrongly, right? So that is probably not what we want. We could, I guess, put this in a method. We could separate this out. We could put an additional check in to see if the user's input was valid or not, set an additional flag, that might be okay. But again, now we're kind of in terms of what we gain from reducing this output to what we gain from having to add this extra method or add some extra flags is equivalent. Okay, so I'm actually going to leave this as it was because I think that's fine for that little bit of repetition, given the reasons that I've just stated. Okay, so again, there are probably a couple of optimizations here, but I think this gives you a nice kind of clear solution. One other thing just to draw to your attention is we could, rather than predicating the solution on the player's lives and whether or not they're in the final room, we could just set a flag here. So we could say Boolean finished. And we could say while finished equal to false, or while not finished, if I could spell finished. long day, as I'm sure you can tell. Then inside here we could have a little bit more control over when the loop finishes. So down here, for example, we could kind of test what's going on and set that to be finished. So depending, I mean, this would involve, I think, perhaps replicating this check a little bit so we could control what's going on here. But yeah, this was one of the solutions that would be possible. But again, it would result in a little bit of repetition. But again, then we would gain if we had finished here. When we actually put checks inside the while loop, we limit the extensibility of our program just that little bit. So if we want to, for example, come along later on and check whether the user enters exit, then it would be a little bit more work to change the condition inside the while loop. Whereas if we have this finished flag, it's a little easier for us to interact with things. Okay, so that was another possible option. If the TA talks to you about that, again, it's because it gives us this little bit of extra flexibility. But in general, you know, I think having the conditions up here is fine. Because if we have this flag, of course, we might need a little bit of repetition. So we would need to check each time around the loop whether we finish or not. And then we'd have to repeat this, finish the game or lost the game inside each of these outcomes, I believe anyway, just looking on the face of it. Okay, so just to bring you aware of that. All right, so now we can put this back in and the game should be working as we expect. All right, so there's one solution. There's I think the majority of the functionality. As always, I'm doing these completely off the cuff. So if I miss anything, let me know. I'm happy to make additions, etc. But I think this gives you a good idea of the kind of solution that we were looking for, the kind of things we were looking for. Key points are the use of input. So you should make sure you're happy and comfortable with how input works. And also this idea of states, this kind of linked list that we create between the rooms and how we don't need additional checks inside here. We simply just ask the player to move to whatever is connected to their current room. And because we update that current room again, we can move through our rooms in this way. Thank you. Hopefully useful for you.